Good morning, Physics 30 students. Hopefully you're all warm somewhere and you're safe. I'm sending you out the lesson if you didn't get it from Remind 101. If you can please zoom in over here. So we are going to review the curve straightening technique that we learned last day that you were all here. We'll review that when everyone is here. Page 12, questions 1, 2, 4 to 7 are optional from kinematics. If you feel you need review from Physics 20, do this. Page 16 is on dynamics and forces, questions 1 to 3 and 4. Note the answers have a lot of prefixes, so please, if you think your answer is wrong, double check. Quite often the answers aren't in scientific notation, but they're using prefixes for this. Page 21 is very important. It's adding 2D vectors. We need this all throughout the course for the standard of excellence, and it is questions 1 to 5, 7, and 11 through 13. Now follow me over here, please. So from Physics 20, I will send out a picture of this adding 2D vectors. Make sure you draw a very labeled vector diagram. You're going to find the x and y components. You need to add all of the x's together and all of the y components together. And step 4, you're going to draw and solve. Draw a new vector diagram and solve using Pythagorean theorem for the side, for the resultant, and the angle with inverse tan. So here's how the picture looks. When you go to the problem set on page 20, they've given a lot of the vectors drawn together in one large diagram. Please make sure that you draw each individual diagram and you show me the x and the y components on each angle vector. Okay, and then over here, come closer please so you can see over here please, thank you. We also use what's called horizontal projectile motion from Physics 20. This is on page 25, question 13. This is the diagram. Note you need a table of horizontal and vertical. The original velocity that the object, when it's coming off of the top of the table, is 100% horizontal in the vertical plane for the initial velocity. The vertical velocity is initially 0. Some other things we know that it accelerates at 9.81 meters per second squared. We know the vertical displacement. So keeping in mind, using one of the 5 accelerating motion equations from Physics 20, and then for the horizontal plane, it will 100% of the time be v is equal to d over t for uniform motion. Here's what I'm assigning today on Unit 4 on energy, page 29, 1 to 8, Unit 3, circular motion, page 32, 2 to 4, and page 34, 1 and 2. And one last thing, come on over here please, is that I am currently here on page 32 of the workbook. Please note when you're going to do your equations that we do not see this particular equation on our Physics 30 formula sheet. You're expected to build it using Newton's second law, which is written like this on your formula sheet. When we take the centripetal acceleration of v squared over r and we substitute it in, we actually get the derivation, which is the equation we want. And this application will be used in Unit 2 for magnetic fields and Unit 4 for mass spectrometers and particle accelerators. So stay warm, everybody. I'm keeping us on track. Please, if you don't have your workbooks, have your mom or dad or someone safely come in and get them for you. Tomorrow might be a snow day as well. It's supposed to be colder yet. So I am planning, no matter what, we are starting Wednesday morning on Unit 1 momentum. Tutorial will be Wednesday, and I'm going to do a makeup class of instruction for the entire block, so please plan on being there every Wednesday as our assigned tutorial. Stay warm. Talk to you later.